So as we talk about dilations, it is our transformation that actually changes the size of the figure, not the shape, but the size. So when we think about dilation, well, let me step back for a second. When we think about a translation, we need a direction that it's going. Okay, and actually we were moving it along something called a vector, but we were focused more on the coordinate plane. So there's a left to right movement, up and down movement. We couldn't just say it was a translation. We had to get specific so we know where the image ended up. When we dealt with a reflection, we needed a line of reflection. Okay, we can't just say, hey, it's reflected. Well, it's reflected over what? We need to know where the figure ends up. Rotation, we need a center point, which in our case has been the origin, and degrees, which again has been 90, 180, 270, and then counterclockwise or clockwise. Okay, so with dilations, we need a scale factor. It's going to tell us if the figure is getting bigger or smaller and by how much. So, excuse me, a scale factor is a ratio. Okay, so if we have to find the scale factor, you would take the new figure and divide it by the original figure, or the image and divide it by the pre-image. Okay, so this right here is finding a scale factor. So if you're given two figures and it says, hey, find the scale factor, just put the new or the image on top, the original length on the bottom, talking about like two corresponding lengths, and then just divide it. That tells you your scale factor. So if the scale factor is greater than 1, the figure's getting bigger. If the scale factor is less than 1, remember we talked about between 0 and 1, it's going to reduce the figure. It's getting smaller. Okay? So that's a scale factor. A dilation is a transformation, we're talking about that either enlarges, means makes bigger, right? Or reduces the size of the original figure. Okay? And again, I shouldn't say again, but it's like a perspective in art, like it's getting bigger or meaning farther away from a fixed point or pulled closer to a fixed point. So it's going to look larger or it's going to look smaller. It actually is larger or smaller. So to dilate a figure, just like we did on the first video, we're going to multiply by the scale factor. Okay, so let's practice that. It says dilate each rectangle by the given scale factor. Again, you can't just say, hey, dilate it. You got to say dilate it by what? That's the scale factor. Excuse me. So if our scale factor here is 2/5, we're not just going to make this like width here, make it 2/5 the size, but then leave this the same. Because now that figure is no longer a ratio. Okay, the sides are not in the same proportion with each other. So it's not going to work. So you have to do 2/5 to both. Because again, now, looking at 2/5, that's a number less than 1. If it's less than 1, we're going to reduce this figure. If you don't multiply it by both these numbers, you're only reducing one of these sides. So this side's going to get shorter, but this one's going to stay the same. It's not going to look like the same rectangle anymore. So we're going to go 15 times 2/5. We can write that over 1, and then you just multiply it. You can multiply straight across. You can cross to reduce. 2 and 1 have a common factor of 1. Great, but doesn't help us. 15 and 5 have a common factor of 5. 5 goes into itself 1 time. 5 goes into 15 3 times. We end up with 6 over 1. Okay? And do the other one here. Same thing. 35 over 1 times 2/5. Cross reduce. 5 goes into itself 1 time. 5 goes into 35 7 times. 7 times 2 is 14. We end up with 14 over 1. Well, our dimensions then are 6 inches by 14 inches. So this rectangle got smaller. It was reduced in size, okay? But it's in the same ratio, okay? And that's important, okay? If we're going to make this one 2/5 the size, we got to make this one the 2/5 the size, okay? So let's keep going. Scale factor is 3.5, okay? That's enlarging it. It enlarges. Why? It's a number bigger than 1. So we're going to go 10 times 3.5. And we're going to go, well, 10, or you can start with 22. Doesn't matter which one comes first. It's multiplying. 10, not 10, 22 times 3.5. There we go. Okay. So 10 times 3.5 is going to be 35. So that's 35 inches by 22 times 3.5. You type that into calculator, you get 77. And I'm apparently struggling with writing 77. So I'm going to try again. One more try and then I'm done. So it'll be 35 inches by 77 inches. Which makes sense, doesn't it? Don't we expect each side to get larger by 3.5? All right, scale factor 5/3. Don't just say because it's a fraction, it's being reduced. This is also going to enlarge it because this is a number bigger than 1. Okay, but we're multiplying, don't change it to a mixed number. So I am going to go 24 over 1 times 5/3. And I'm going to cross reduce. 5 and 1, just 1. 3 goes into itself 1 time. 3 goes into 24 8 times. Ends up with 1s in the bottom. 8 times 5 is 40. So this side is going to become 40 inches by, and then I'm going to do 30 over 1 times 5/3. 3 goes into itself 1 time. 1's in the bottom. 3 goes into 30 10 times. 10 times 5 is 50. So this is new size is going to be 40 by 50 inches. Is that bigger than 24 by 30 inches? Yes. Okay, so really, that's all we're doing, okay? It's a good habit, though, to anticipate whether it's getting bigger or smaller, okay? So this one here, it's smaller. I should think this is going to be reduced, right? This one be enlarges, and this one's going to be enlarged, okay? All right, so now let's go back to finding the scale factor, okay? So this is finding new dimensions, but let's go to finding the scale factor. We're going to take the image over the pre-image, or new or original, finding the scale factor. So find the scale factor. There's the hint to what we're doing. That was used to create this dilation. Well, remember, I'll just do my work down here. Okay, image divided by pre-image. That is what our kind of definition says over here, right? New over original, image divided by pre-image. How do we know it's pre-image? An image. Well, look at, here's my prime markings, right? So this one is my image. This one then is my pre-image. Now, you don't have to do all the sides. Just pick the corresponding sides, meaning, let's say I focus on G to H. Then I am going to focus on G prime to H prime. Okay? Meaning, G prime to H prime, that's my image, is 10. My pre-image is 8. Well, you can reduce it, divide 10 by 2 and get 5, and divide 8 by 2 and get 4. Okay? Or, if you divide that on calculator, 10 divided by 8, 5 divided by 4, you get 1.25. So your scale factor is either 5/4 or 1.25. This one is 1.25, 1 1/4 the size of this one. Now, the reason I only say you do it once is because if you did another one, let's say you compared like 12 GI to G prime I prime. Well, again, my image is 15. My pre-image is 12. 3 goes into both of these. So if I divide 3 out of both of them, I get 5 divided by 4. You don't need to do them all, okay? Because remember, each side is growing by the same scale factor. So you don't need to test them all. If it wasn't the same scale factor, it'd look pretty weird. All right, so again, find the scale factor here. Throw a new color here. So scale factor is image over pre-image. All right, and then compare two corresponding sides. This one is my image. Always identify your image. It's the one with the prime markings. So let's say I decided to compare x prime y prime to x y. Okay, you always got to make sure that, because it might be rotated, that you're comparing the same two corresponding sides. Well, image, x prime to y prime is 12. X to y is 18. So if you reduce these, 6 goes into both of them. 12 divided by 6 is 2. 18 divided by 6 is 3. And you know what? I'm going to leave it as 2/3 because if you divide it, you get a repeating decimal. Okay? Does that surprise us that this is a number less than 1? It shouldn't. This figure here, our image, is smaller than this one. So therefore, we had to take these lengths and multiply them by a scale factor less than 1. Okay? So dilations, they're going to change the size. We're going to enlarge or we're going to reduce. And to do that, we need a scale factor. Scale factor bigger than 1 enlarges, less than 1 reduces.